So this is going to be the second part of those notes from Unit 5, Note 2. So let's take a look at number 6. So the equation y is equal to negative x squared plus 4x plus 3 represents the height of y of a flying disc x seconds after it is tossed. When will it return to the ground? So really the ground is being represented by the x-axis. So we need to figure out when it's going to cross the x-axis. Well, in order to do that, we need to graph it. So in order to graph it, I first need to calculate out the vertex. So I'm going to do opposite of b over 2 times a. So that's going to be negative 4 divided by negative 2. So I'm going to get that x is equal to 2. Now I need to plug that in for y. So I'm going to take x out and I'm going to put 2 in instead. So then I'm going to get, once I do that, 7. So the vertex is 2, 7. So I'm going to go ahead and make my chart. So 2 is going to be in the middle. We're getting bigger going that way, and we're getting smaller going that way. So 2 is going to be 7. What I would like you to do is plug 3 and 4 in for x and pause the video. I'm going to fill the chart in, but I want you to try it on your own. Make sure you're plugging it in correctly. If you're not, come and show me and I will help you. So go ahead and pause that video. So there's your chart, okay? So we're going to go ahead and plot some of these points. So we're going over 2 and up 7. That's this point right here. Then for 6, we're going over 1, up 6. We're also going over 3, up 6. Then we're going over 4, up 3, which is here, and over 0, up 3. So this right here represents our parabola. So I'm going to go ahead and draw that going down. Okay, so this actually represents the path the frisbee takes, or the flying disc. I guess that's the same as the frisbee. So it's going to go up and it's going to come back down. So this point right here is when it hits the ground. So I want to figure out what the x value is. To me, it looks like it's crossing between 4 and 5. So to me, I think it's going to return to the ground at about 4.5 seconds because that's where it's crossing the x-axis. And typically in these type of problems, the x-axis is going to represent the ground. All right, let's go ahead and let's take a look at number 7. So we want to find the vertex and the axis of symmetry for part A. So let's go ahead and do that. So we're going to do x is equal to opposite of b over 2 times a. 12 divided by 2 times 0.5 is just 1, and 12 divided by 1 is just 12. Okay, so let's go ahead and let's take a look at what our y value is going to be. So we're going to go ahead and plug in 12 for each of our x's. So you're going to take 0.5, make sure you type 0.5 into your calculator. 0.5 times 12 squared minus 12 times 12 plus 150 is going to give you 78. So your vertex is 1278. Cool. What is this problem? Okay, so what we're modeling is the monthly operating cost for making wedding cakes. So if you remember back to the first note video, we talked about how parabolas are representative and the vertexes represent maximums or minimums. Okay, so if we're trying to figure out the minimum cost, okay, we're going to need something in the vertex. Okay, now it says here that y is the total cost. So if we're looking at the vertex and we want the minimum cost of the vertex, it's going to be 78. So $78 is the minimum cost. Minimum tells us vertex, cost told us the y-axis. Coordinate, sorry. So x is equal to the number of cakes that are prepared. So how many cakes do we need to prepare to yield the minimum cost? Well, that's just the x coordinate of our vertex, which is 12, and we want to make sure we label that cakes. So that concludes the second part of the note video, so you should be ready for your practice sheet word problems once you're done. Thanks for listening.